Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
As you may very well know, we are playing around with Sentinel images, Sentinel daytime images, specifically Sentinel-2 in images, specifically surface reflector images. So we've been playing around with the multi-bands, trying to generate a number of indexes or indices. For example, we first looked at the normalized difference vegetation index. Now we're focusing on the past video or two. We have been focusing on trying to determine or trying to use indices that specializes, if you want to call it that word, in highlighting or identifying built-up areas, urban areas, structures. So that's what we're interested in working at the moment. So we're looking to say, okay, there's my region of interest. Okay, I have a daytime image of it. Sentinel in this case, can be Landsat as well, but Sentinel in this instance. Let's try to identify built-up or urban areas within my region of interest. Okay, so we're looking at various different indices that can possibly achieve this. Remember, our biggest issue, biggest concern, or biggest problem here is that urban structures and bare soil or soil are very, very similar in its reflectance, in its surface reflectance, meaning its spectral signatures. So it's very difficult to distinguish between the two classes. So that's why we have different indices. You'll see there's a number of them. And that's why we have different indices, each with its unique band combinations to try to isolate or to split urban structures from bare soils. And that's what we're trying to do at the moment. So we're going to play around with a number of them to see which one of them gives us better results. Okay. I'm referring to a article. Let me make this a bit bigger. I'm referring to this particular article. Determination of urban areas using Google Earth and spectral indices, and that's a case study in 2023. Now, I'm following the methodology of this particular study, but I'm not using Landsat. They've used Landsat images in this study. I'm using Sentinel images. Now, the table that's of relevance is this particular table. Okay, let me see if I can make it. And you'll see there's a number of indexes that we are using. There's the urban index, a normalized difference tillage index, normalized difference build-up index, new build-up index, normalized build-up area index, band ratio of build-up area, build-up extraction index. Okay, normalized vegetation index we've already done. Soil adjusted vegetation, enhanced vegetation image, etc. But you'll see the majority of them is related to build-up areas. And as I said, they use different band combinations or different bands and band combinations within different equations itself. But you can see if you look at all of them, they mostly focuses on the red, the near infrared, and the two shortwave infrared bands. The majority of them, you can see there, shortwave, near infrared, shortwave, near infrared, shortwave, red, near infrared, shortwave, here's a one with green, there's a red, shortwave, red, shortwave, okay, there's one with green, there's the near infrared, the red, near infrared, red, etc., etc. So you can see there's a number of them, but they all work within that 3 or 4 bands, and then they just rearrange the combinations and use it in different equations to generate different pictures. And I said the whole idea of this is to identify built-up areas, urban areas within my region of interest separate to bare soils. So that's what the whole thing is all about. And then, as I said, the second important one of them is this particular table where he creates these thresholds. So for each of the indices, okay, so for each of these indices, he creates a threshold where if the value lies within that specific range, then it generates, or then it can be classified as an urban structure or urban area, versus if it lies in this particular range or threshold, then it is bare soil. So it's trying to distinguish between urban areas or urban structures and bare soils. And you can see the numbers. There's obviously some overlap. You can see in some of these places there's some overlap. You see there's 0.9 to 0.18 and there's 1 to 0.6. So there's definitely some overlap, and I said that is where it complicates, the thing becomes very, very complex. Nonetheless, it's worthwhile. It's a good exercise to go. Let's see where we get. Okay, so with this study in mind, with the indexes, with the thresholds, let's go for it. In the previous one, in this video tutorial 93, okay, in this video tutorial 93, we generated a normalized difference build-up index. But if you watch that video tutorial, you see that I made a comment that I don't put a lot of emphasis or importance on that specific index. I don't think it's very useful on itself, okay? But remember, I also said it's useful in that you need it to create what we call a build-up index. Okay, so if I go back here, you'll see that, let's quickly just go there. There's my build-up index that I'm going to generate now. And the build-up index uses a normalized difference build-up index. Okay, the normalized difference build-up index, this one here. And you subtract the normalized difference vegetation index. This one here, normalized difference vegetation index, this one there. Okay, so although this one, the normalized difference build-up index by itself, in my mind, remember this is my view, not fact, just my specific view, that it doesn't really matter. It's not a very good indicator of it. It blurs. It's not very nice. Go and play around it. You'll see for yourself. I don't particularly use it. However, this one, the build-up index, is intimately better to use. Okay, so this one is much better to use than the normalized difference build-up index. Okay, so I personally like this index. I think that's something that we can work with. But to do this, you need those two indexes and you subtract them. Because remember, the normalized difference vegetation index, normalized difference build-up index are basically inverse of one another. They're basically the inverse of one another. So, for example, where there's a lot of vegetation and healthy vegetation, one would assume there would be very little urban or built-up structures, urban areas, and vice versa. So that's why I'm saying these two should be to a large degree inverse from one another. Okay, anyway, enough of that. Let's go and have a look at it. Okay, so we go to our code, our script, our project. I saved it as Sentinel 1. And I generate my build-up index for 2024 and 2028. So my build-up index is my normalized difference build-up index 2024, subtract by my normalized difference vegetation index, and I call it BU for build-up index. And I do the same for 2018. Okay, exactly as what is indicated in this particular table. Okay, so I follow that table. So I now have generated. Now I need to display it. Okay, but remember, first port of call is I'm not sure exactly what my visualization parameters, specifically the minimum maximum value, should be. I'm not too sure about that. Okay, so I run my min and max script. I run my min and max script. Okay, remember I went in quite a bit of detail in the previous two videos about the scale value of 900. For every scale that different scale that you're going to use, you're going to get a different min-max value. So you'll have to use a scale value whereby you create a min-max value that sort of makes sense. Because remember, there's certain criteria that they have to either -1 to 1 or something to that effect. So have a look at that, and also you can use the inspector and then see what the range of those values would be. Nonetheless, I get my minimum value minus 1.2 and my maximum value 0.87. 0. Make it 0.88. 0. Okay. So I include that is my min-max values. I give it a color scheme. Okay. I give it a color scheme. So there's my visualization parameters are sorted. And then I present the data. I create the image, I present the image, I display the image. And there is the 2018 image. That's 2018, and there is 2015 image. Let me just move it a little bit there, make it a bit bigger there. Okay, that big. Okay, so that is 2018. Let's go back. You can see 2018 much more red than 2024. Much more red than 2024. Much more red, specifically in this area, than 2024. But you can clearly already see here that most of this red that you find here, most of this red would be bare soil. Because you have an urban area that's located there, you have an urban area that's located there, you have an urban area located there. But you don't have urban areas here. These are all agricultural land. And a lot of them are land that specifically in the summer season lie fallow because it is seasonal crops, so winter crops. So summertime, January, December, January, February, March, that area will lie fallow. It will basically just be sand until it's plowed and the rain comes, etc., etc. So that's, again, why when we start, rather use the seasonal images where the seasons by itself minimizes the bare soil. Okay, but obviously we're going extreme now because we want to test it in the extreme. It's no good testing it for when everything is perfect. Let's test it for when everything is not perfect and then see what happens. Okay, so obviously you should understand all this red is not urban and urban areas, urban structures. I mean, that would just be crazy. Okay, so obviously this here's already a problem. Okay, here's already a problem. Okay, so let's have a look and see if I take, for example, my 2014. Let's play around with the visualization parameters. We can play around with that. Okay, so remember that's that. I can change my range. Remember, I've got my range here, 0.3. Let's see if we custom that range, see if that something happens. See if that looks a little bit better. No. Still a lot of red. Still a lot of red, but there's less red than what there were previously. Let's remember, stretching here just means you change the numbers here, meaning you're putting different thresholds in. Okay, so let's go stretch 2, see what that means. Let's see what that color scheme looks like. This looks already a little bit better. You can see it's much more reds. Definitely much more reds, or less reds, sorry, not more, less reds. You can see, but we need to actually drill into an urban area to see if it highlights that urban area. So let's go into this urban area and see if it highlights this area. You can see the urban area there. Let's have a look and see. So that's why it's important to play around with this min-max value. That's sort of the key. You can see here. Let's have a look. It's still loading, unfortunately. It does take some time. Aha, look at that. Look at that. But you can still see it does include this urban area quite a bit, but you can see the sandy area, even the water, this area. So it still has a lot of reds. And you can see some of this urban area here is a purplish color, a bluish color. Let's try stretch 3 and see what that looks like. You can manually change these numbers as well, okay? You see there now it doesn't indicate anything at all. Now it basically there's no reds, so that's not going to work. So let's try this one. As I said, you can change these numbers. Now it becomes like a yellowish color with other screen, but you can still see even it's yellow. These sandy patches here. Let's go stretch 89. But I'm moving further away. Oops, sorry. So this is all going the green way. So most probably if we go to stretch 2, I think. Or stretch 1. Yeah, most probably stretch 1 looks like a better option. If I go out, let's have a look and see. So I'm not gonna close it. I'm not sure if it's gonna take now. Yeah. It's starting to load. Let me just go back to the code. Where are we now? Come on. Build-up index. Sorry, I'm just going to get my... There we go. Okay, so there's my... You can definitely see using that particular minimum and maximum range obviously improves the layout quite a bit. It does eliminate a huge amount of the red parts or the sandy parts, but it also makes your urban areas less likely or less visible. Okay, so so what we're trying to do now is to say, okay, now let's try to do this manually. Okay, because if we use this index, most of this visualization parameters function here, then yes, you can change it, but you have to do it every single time. It can become cumbersome. So we're going to make use of a less than and a more than function here, okay, so that we can isolate that range in which the built-up areas or urban the structures is more likely to be, i.e. that particular spectral signature. Okay, remember, if we go back into this journal or this article, it indicates that the build-up index, we're busy with the build-up index, this one here. Okay, we're busy with that. The urban should lie between minus 0.3 and 0.35, so closer to the 0. And soil should be from minus 0.10 to 0.6. So you can see there's a bit of overlap, so unfortunately, which is expected. But you can see there's some place where, or some range from this 0.35 to 0.6 that is for soil and won't include, and to the other side as well. So the overlap is actually quite small, but that doesn't mean that it's less significant. Okay, so this is what we want to do, is we want to create a threshold to try to isolate only urban areas. But with the understanding there is some overlap with urban areas and bare soil. So let's quickly try that. Okay, so let's try that. I'm just going to minimize it here. And so the first one that I'm going to do is I've already used these values. Okay, remember this is for Landsat. This is for Landsat. So we'll have to find our own values. Okay, but I initially started with these values. Okay, so let's put them in. Oopsie. Let's put them in. So it is less than minus 0.30. Okay, so let's go there. Minus 0.30, minus 0.30, and more than 0.35, more than 0.35. Okay, so I'm saying here, I'm going to mask all the areas that's outside my range or my thresholds, and my threshold is 0. Smaller or less than 0.3. No, sorry, it should be more than, less than 0.35, sorry, and more than minus 0.30, sorry, opposites. Okay, so I'm trying to look at the index values between minus 0.3 and positive 0.35. So I'm looking at from smaller than 0.35 and bigger from minus 0.3. So that will give me that range around, let's say, the 0 value. Okay, so I'm not looking for values close to -1 or values close to +1. I'm looking for values around the 0. Okay. Let's leave the mask out for now, and we're gonna then give it a color which is 0 for, remember this mask means that all those 0 values will not be displayed. So for now, let's display it because I want the backdrop. So 0 if it falls outside that region, 1 if it falls within the region. So therefore black would be the 0 and 1 would be the red. So I'm only interested in the red. And I then run it. Okay, and this is what it looks like. Okay, so this is what it looks like. Oh, no, sorry, run. That one that I just explained was my change. I should have copied it now. That was not stupid of me. I should have copied that. But anyway, it's too late now to change it. So I can't remember the numbers. Can't remember it. Let me just deselect. Otherwise, we'll sit here till tomorrow morning and waiting for this thing to offload. So we're doing the build-up index 2024, 28, and the mask. Okay. So let's quickly wait and see what happens. Okay, so remember we're saying that within that range, ideally, that should eliminate all non-urban, non-built-up areas. So within that range, it theoretically should only display built-up areas. But you can see everything basically is red. You can see everything is basically red except the river and the mountains. Okay, so this range is no good, doesn't work. And why doesn't it work? Because in this article, it uses Landsat, not Sentinel. So we must use Sentinel values, not Landsat values. But nonetheless, it gives you a starting point, for better or lack word. So let's change this to, what shall we? Let's go to our built-up index. Let's go and find an area, and let's go and click on it using our inspector to get an idea. Okay, so we're going to click on that one there. So let's click on that one there. So let's click on it to get an idea of the value. And so we're looking for build-up index 2024. So we're looking at a value of 0.135. So obviously that value is way too much. So let's make that 1.5. Okay, so let's click on this value here. And this open soil here, let's click on that and see what that value comes from. And that value is very similar. You see, that's a problem, 0.36. Let's click that one there. So I'm okay with that value, less than 0.15. You see, it must be 0.05. So that's much bigger than that. So it's going to exclude this area here. So let's make that, let's leave it for now. Okay, so let's start with that value. We're going to look at that value later. Okay, so let's run. So I've decreased my maximum value. I've decreased my maximum value. Okay, let's quickly go there. Here we go. And see what that looks like. So again, let's just unselect all these other layers. I've set the normalized difference build-up index. It's not worthwhile standing still on it, except as I said for using in this one. Okay. You can see it's already better. Oh, no, sorry. Still loading. Still loading. Oh, still a lot of red. Still a lot of red. Okay, so let's change this one to -1. Let's change that to -1. Let's run it again. Unfortunately, this is pretty much, wouldn't say guessing, but it's certainly a little bit of a hit and run exercise. But who cares? As long as you get to the right answer or to a better alternative or better solution. Okay, so let's have a look and see now what it looks like. Now it's much more black. You can see we definitely decreased the amount of urban areas. Okay. So, but now let's have a look and see in our urban area, what does the color come from? What is presented here in that specific threshold configuration? Let's take to the 18, we're not interested in that one. Yeah, it does show the red. You can see they're nice. Yeah, it does show the urban areas. You can see there and you can see there, but it also includes this area. So we go one step. Shall we advance one step? Okay, so I am thinking that we must probably find it. Where is it? Normalized difference build-up index. I'm thinking that we should go this one. So let's make it 0.5. See, it's very narrow, huh? Extremely narrow, the band for urban areas. But that does make it a lot better. Huh? It does improve it quite a bit. Okay, so let's click here around again. Let's unselect all these inactive layers because we're not using it. Okay, so make it bigger again. Go to our build-up area. Okay, so there's our. Okay, so now let's have a look and see. And remember, I'm. Why is it not? There it is. Okay, so now it's got very little red. But now let's see. I think. Okay, we're just waiting. We're just waiting. Okay, so that looks a little bit better. The build-up area is still pretty much, but I'm losing some of it. But again, you can see this area here. So let's try make this smaller, make that 13. I think let's stick with minus 0.5 here, 0.05. Let's take that 13 down from 15. But you can see we're decreasing the amount of soil, that's for sure. But we're not diminishing the urban areas that much. So as long as you can do that, diminish the soil areas, make that less and less and less, but keep the urban areas, urban structures, surfaces still intact. Then you can continue with this exercise. So, but we're now getting to the margins. We're now getting very, very close to where I think you can't do much more to it. So let's quickly unselect the layers that we're not interested in, and make it bigger. Okay, so let's quickly. You can see there's very little. I don't know why. Only wait a second. You can see most of it is non-urban areas, but you can see there's quite a bit of urban areas. So proposed urban areas according to this. New build-up. Sorry, I'm just going to quickly get to where I am. I keep on losing my track. I must make a mental note of it's 250. Okay, it's 250, 251. Sorry, not 250, it's 266. So you can see already there's much less, but I'm concerned that we're in that range now. If we're going to change it either way, we're going to also diminish our urban areas. So we're basically in this overlap place, in this overlap space. Let's quickly have a look and see. I can see we're starting to slowly but surely diminish it, but it's still reasonable. But you can see these sandy patches still exist. Now I'm almost sure that if we use the winter images, it will be much better. But let's quickly activate the self mask, because now we're only going to display the so-called urban areas, urban structures, urban surfaces. So I'm not going to use the black. So now what we can do is we can overlay it. We can overlay it with our actual Landsat image. So we've got here's my Landsat image. Okay, so we can overlay it with my Landsat image, and then we can see how accurate it is. So there's our Landsat image. So it only displays the red. Whew, there's still a lot. Look at all this. There's still a huge amount of red. Let's see. Which according to this index is supposed to be urban areas, but it's clearly not urban areas. It's mostly sand. So can we maneuver? Can we still maneuver? Can we still change this? Can we do it? Well, I'll leave it in your hands to see if you can do it or if you can continue. But point is, you just continuously adapt the two values here, the maximum value and the minimum value. And so you just maneuver those two values, change it here and change it there, run it, compare it for accuracy test against the actual Sentinel image, and then compare it. Now, you're not going to get it 100% correct in that it will only show urban areas simply because of the bare soil issue, but it's nonetheless, it's possible to keep on playing. Now, obviously it doesn't look lacquer, but as I said, it's not the final index. There's still, according to this article, if we go to this article, you'll see there's still, where is it now? There we go. There's still a number of other indexes. And according to this article, this is a fairly low ranked index. This is a fairly low ranked index, meaning its accuracy is not that great. Its accuracy is not that great. So don't despair. What we're going to do is we're going to go to the next index, and that's called the urban index. The urban index. Now, if we go to the article, that's the urban index there. Urban index is a shortwave minus +1. So let's have a look at the formula there. Okay, and then add the 1. Okay, and then multiply by 100. So the next one we're going to look at is urban index, but you can see it's still using shortwave, infrared, and near infrared. All I'm doing is now I'm adding these two things. I'm adding this to. You can see the normalized difference build-up index. It's exactly the same, except they use 2 and this is 1. But it's the same principle, except now that we add 1 and we multiply by 100 to give you a percentage. So that's the one that we're going to play around next. Okay, so this is our first shot of determining urban areas or urban surfaces, urban structures by using the build-up index. And then we played around with the thresholds to try to isolate build-up areas. But still, the problem persists between build-up and bare soil. So we're going to try the next one, okay, which is called the urban index, and see what that looks like. Then there's still the new build-up index. Then there's a normalized build-up area index. And then there's a ratio of build-up index. So we're going to go for all of them, but we're going to continue applying the same methodology. Calculate the index, visualize the index by using our min-max parameters, and then from after we visualize it, we're trying to isolate by using the threshold methodology, And threshold images, we're going to isolate build-up areas and compare to that. And then we're going to look and all of them to see which one is the most accurate, which one is the most reliable or best used to present urban areas in the face of bare soil. So that's what we're going to do for the next couple of videos. Well, I hope you enjoy it. Thanks for your company. I really enjoy your company. It's always fascinating to have you on board. I love having you on board. And stay tuned. Next videos are around the corner. Please remember to like, subscribe, share the video, press the notification bell. We're trying to upload a couple of videos per week. We're starting, I think, at 109 videos. That number needs to significantly increase. So yeah, thanks again. As I said, please remember to press all buttons. Just press a button, please, please, please. For those that have subscribed, many, many thanks out of the bottom of my heart. I really appreciate it. And yeah, I'll see you on the other side.